back. In this video, we'll be discussing the different kind of analysis you can do in order to test your hypothesis. There are different analysis techniques out there, again, that will allow us to have an answer to our research question. So let's go ahead and discuss these one by one. So ideally, the first thing you need to understand is we have hypotheses that have been developed using our framework. We have collected our data in order to measure our variables. Again, some variables need to be measured using specific scales, or maybe as simple as a Likert scale. Our variables could be either dependent variables, independent variables, or control variables. All these, again, we have discussed in the previous video. So once we have collected our data, we need to do hypothesis testing. So what is hypothesis testing? Hypothesis testing allows us to make inferences about the population based on a sample data. That's the whole point. For example, if I want to find the average weight or the average weight of people in Lebanon, in the whole Lebanon, the population is Lebanon. I cannot go and ask every single person in Lebanon what their weight is. It's impossible, If I can, then basically a hypothesis, we don't have a hypothesis. It will be a fact. I'm going to go ask 200 people, 300 people. Using these 300 people that I asked, which is my sample, I will make an inference about the population. Hence, this is what we call hypothesis testing. And any research you do, you need to end up doing or making hypotheses or making claims that you will be testing using the data that you have collected. So again, it's a process where you test a claim or an assumption about your data. Again, whether two variables are related, a specific condition is true. All these are part of hypothesis testing. So let's go ahead and look at the most common analysis or techniques that we can use in order to test our hypothesis. We're going to start simple and then expand to more interesting ones. So the famous or simplest will be a t-test. T-test, we use them when we want to compare the means of two groups to see if they're significantly different from each other. Okay? So in other words, I want to compare the mean or the average of two groups, only two. I keep on saying two because if it's more than two, we use something else, which is ANOVA. But ideally, a t-test could be either independent test, independent t-test, or a paired t-test. You say, what's the difference? They're the same, more or less. But the independent are based on two independent groups. Again, comparing satisfaction levels between male and female respondents, for example, in college. This is a very simple example of finding the average satisfaction of male, the average satisfaction of female, and using an independent t-test to compare the averages and make a conclusion about gender and their average satisfaction. If we want an example of a paired t-test, it would be most likely before and after, a pre and a post test for the same participants. For example, students in my class, same students, before giving them the technology and after giving them the technology or the educational technology and looking at their performance, for example, their average performance, their average GPA. This will give us an idea of before and after looking at an average. So a t-test, one more time, we're comparing averages. A chi-square test, which is another kind of test, in this case, we're looking at categorical data, okay? Look at an association between two categorical variables. Categorical meaning you don't measure it. Think about it as qualitative, okay? Qualitative versus quantitative that we measure. So, for example, if you survey students about their preferred learning method and their gender, you want to look at a chi-square to check if learning preferences vary by gender. I'm not looking at the average here. I'm looking at gender association with learning preference or learning preferences and gender. So this is kind of looking at association between qualitative variables, because gender, you cannot measure it. Learning preference, you cannot measure it. They're not quantifiable. So I have these categories, and I will look at the association. You will end up using a chi-square test. So we talked about the t-test to compare averages between two groups, either independent or paired, meaning dependent, pre and post, before and after. Chi-square test to look at association between categorical variables, meaning variables typically you can't quantify, association between them. I give you an example, learning preferences and gender, for example. Correlation test, meaning is there a correlation? Is there what is the strength and direction? So is it negative or positive? And how powerful is the relationship between two continuous variables? Not discrete, most likely continuous. So to do that, we usually use the Pearson's correlation, which is the R, you could find it, and we make an assumption that it's normally distributed, meaning it's like a bell. So this is when we use the Pearson's correlation to test the relationship between, again, continuous variables. Example, test the relationship between study hours, how long you study, and your test scores. Is the relationship, the more you study, the better your scores are? This is where we will end up using Pearson's correlation. Again, if it's not normal, again, assuming it's not a normal distribution, the data is kind of scattered differently, you can use another correlation test, which we call Spearman's correlation. So you have Pearson's correlation, you have Spearman's correlation, both of which allow you to test the strength and the direction of the relationship between continuous variables. ANOVA test, which I kind of implied 2 seconds ago, same like t-test, but I'm comparing the means of 3 or more, not only 2, 3 or more groups to see if there is a statistical significant difference between them. So I'm comparing means like the t-test, the averages, because that's the most thing we usually common that we actually compare. For example, comparing the average satisfaction scores from students in 3 different universities, AUB, LAU, and NDU. So these are 3. I want to look at the average satisfaction of students to see if one group differs significantly from the others. This is where we end up using ANOVA test. Okay, so ANOVA is like t-test, but it's bigger, more than 2. Okay. Regression analysis, very similar to the Pearson correlation. I just talked about it. Usually we do, again, regression is very common with machine learning, big data analytics. We look at, regression analysis a lot. But ideally, it could be simple linear regression, very similar to Pearson's correlation coefficient, predict an outcome based on one predictor variable. For example, predicting student performance based on study hours. The same example I use for Pearson correlation. So yes, simple linear regression is basically using Pearson's correlation coefficient to measure the strength and maybe do predictions as well. Now, you could have more than simple, hence multiple linear. We're still saying linear, meaning assuming the relationship is a line. It could be nonlinear, that's another thing. But for now, we're assuming multiple linear regression, like before, predicting an outcome based on multiple predictors. For example, predicting an exam score, like we said before, based on study hours, attendance, motivation levels. I could keep on going. This is, in this case, a multiple regression. One output, the score, based on multiple predictors. Okay? So that's regression analysis. What else? Let me just give you one more. This is more complicated, but very interesting for those who want to dwell in the details. The SEM, and that's the very most common technique now. Think about a regression on steroids, So regression plus. This is what SEM is, structural equation modeling, which allows us to test complex relationship between multiple variables at the same time. That's very interesting. The at the same time is what makes it interesting, including direct and indirect effects. So that's what structural equation modeling is. So think about it, as I said, as an extension of regression analysis, with added flexibility that allows you to build models. Usually we have two kinds of models we could build. We have the measurement model and the structural model. The measurement model will allow us to test how our questionnaire is indeed measuring the latent constructs. Meaning, in other words, does my survey questions truly measure what I want to measure? Okay, for example, job satisfaction. I want to measure it. It will, based on SEM, I could use a measurement model to tell me or give me that information. The structural model tests hypotheses between relationships or relationships between different constructs. At the same time, as I told you, for example, you could say, does job satisfaction influence employee performance? And does work-life balance mediate this effect? You could say at the same time, I could look at the relationship between these two and maybe another variable as a mediator. So SEM is very useful, a bit complicated. Again, there should be a whole course on this. But in terms of research, you could read about this, but it's not that difficult to do once you understand. You will build the model with the variables and the hypothesis and the mediators, testing multiple dependent and multiple independent variables at the same time, looking at mediating and moderating effects, latent variables that usually cannot observe them. For example, motivation, customer satisfaction. Usually these are very common when we look at SEM model. Just to end this video, how do we know which test to use? Most likely you will be using most of them, if not all of them. If you have multiple hypotheses, each one of them will be using a different kind of hypothesis testing. I hope you enjoyed this. I will see you in the next video.